how we are going to host a application using the Docker container. So basically, when you are developing any source code, okay, you will build the source code so that it will create a binary file for you. In a Java world, you will be writing the Java code, and when you build it using some build tools like Maven or and it is going to generate a war file. So that war file, you will be deploying it on the target server. So for that, you will be using applications like Tomcat or WebLogic. In that, we will be storing the war file, and the war file will be deployed on the Java platform, via Tomcat or WebLogic. And from there, the customers or the users will be accessing the application. Okay, let me see how we are going to mimic the similar kind of thing with the Tomcat based application. So we are going to take a simple Java source code. We are going to build it, and we will generate a var file. Okay, and with the var file, we will be taking a Tomcat image, and in the Tomcat image, we will be deploying the var file, and we'll be hosting the application. So this is the first example we are going to see today. Okay, so for this, I have a sample Java application on my GitHub directory. We will use it. So GitHub. This is my application where I have the Java application on this location. Okay, and there I have a form.xml, which basically uses a Maven to build the application. This will create a var file. Okay, and that var file, I am going to host it using the Dockerfile, which is already available there. So in the repository, I already have a Dockerfile that will be using Tomcat as a image, and there I'm going to copy the var file, and from there I'll be hosting the application. So let's see this example. For this, first I want to have the Git installed on my machine, and with that I will also need to install my Maven application. So let's do that. So let's go to the directory. So there, just ensure that you are in the root directory, and then let us install sudo yum install git. So this will install git on my machine. So we will run this. I need a git client to pull the source code. Okay.
Yes.
So, okay. So this Java application is built using Maven. So I need a Maven file. I need to install Maven on the machine so that I will be able to build and generate a var file. Okay. So let's install Maven on the machine. So sudo yum install Apache and yeah, I need to install the Maven repository because the default Linux repository or the Amazon repository doesn't have Maven available. So let me install a Maven repository. So this is the command I can use. So if you see that there is a Maven repository which is available on the internet. So I'm just going to download it, and I'm going to paste it in the yum-repos.d. etc yum-repos.d. So this is the directory. You can see all the repositories. You can see multiple repos here. So this is the file I have downloaded now, EPEL Apache Maven repo. So this is going to have from where I can download the, what is the URL from where I can download the packages. Okay. So like that, this is the default repo. You can see this here. So this is going to provide the URL from which URL I can download the binaries which are required. That's what I have done. So in the Maven, so this is the URL, it is going to do that. Okay. And in this file, I'm going to update my version using a command. So if you see that, it is referring to the release server, right? So the release version I'm looking for is 7. Okay. So let me run the command. So let me change this to 7. Because the Amazon Linux, what I'm using is kind of a CentOS 7. So I'm just changing the release server to 7. Run this command. And after that, I can run the sudo install -y apache. So Maven needs Java and JDK. So it automatically downloads that and install it for me. Yeah, it is installing Java 1.8.0. That is the Java version I needed for the building this application. So my Maven installation is completed. So to check the Maven version, you can run the command -open version. You can see Java version is using 1.8 and the Maven version is 4.14. This is my kernel version. 3.5.2. It's printed in a different color. Okay. I'm using Apache Maven 3.5.2. So now let us clone the repository and then we will run the Maven command and create the jar file. Okay. So give you the URL for the Git repo. So ensure that you are in the home directory, type cd and press enter. Git clone this URL. So this will download the repo onto your local machine. So if you do a git clone, it will create a directory called Java Hello World. Go inside the directory. So if you see the directory, you can see it's having only the source directory. Inside that I have the jar file and I have the form.xml. This is going to have my instructions to build the application using Maven. Okay, so let's run that. So the command to build this, compile this code is Maven clean install, MVN clean install. So let me run this. So this will automatically download all the dependencies for my Java application. Okay, and it will create a WAR file for me. So you see that it's downloading all the dependent libraries. So this is going to go to the Maven repository and download all the required libraries for the Java application. It is after that it will build and generate a WAR file for me. So once the build is completed, you should see a build success. That means your build is completed. And if you see, there will be a target directory got created after the build. So inside this directory only, I'm going to have my WAR file. The Maven build got completed and you see a target folder. So to host this WAR file, I'm going to use Tomcat image. Okay. Dockerfile. So there, I'm actually going to use Vietnamese Tomcat. Vietnamese Tomcat. So this is a pre-built Docker image where I have to just copy the WAR file to a particular location. Then it will host my WAR file for me. So it is expecting, okay. So this is the command Dockerfile I wanted. So I just need to copy the var file to this OPT Bitnami Tomcat Web Apps default. In this directory, if I put my var file, it is going to host the application for me. Okay. So let's do the same thing on the Dockerfile. So for this, I know that inside the target directory, I can see this var file is available. This is the var file. I want to deploy it inside the Tomcat container. So let's do one thing. Let me. So inside the Java Hello World, I have the source. Inside that, sorry, not the source one. Where is the Dockerfile I have? Source main Docker. Yeah, this is where I have the Docker file. So cd source main Docker. So let me read the content of the Docker file. So it is going to use Bitnami Tomcat. This is the from, and in the copy command, I'm going to. So this is the file, and this is the file I have, Docker Java sample web app 1.0 snapshot, and I'm going to place it inside the image on this directory, OPT Bitnami Tomcat web apps default. Okay. So for this, I need to make sure the var file is available in the same location where the Docker file is there, because I'm using a copy directive. Till now, we haven't used this directive. We are just using some of the other files like run from expose cmd entry point. So the copy directive will copy the file from the host mission to the container or the image. Okay, so I'm expecting this file to be available on the same location. So let's do that. cp double dot slash double dot slash double dot slash target docker dot var. So this var file, I'm going to copy it to the local location. So in Unix or even in Windows, double dot represents the parent directory. So I'm inside my Java Hello World source main Docker, but the file is available 3 directories up. That's why I have put double dot thrice. And after that, I have the target and I have the var file there. So I'm copying the var file from that location to dot means current directory. So I'm copying it to the current directory. Okay. So once the copy is done, let me build the Docker file. So the command is docker build -t. Let me call it as Java app dot represents the location where my Docker file is there. So it will download the Bitnami Tomcat because I don't have the Bitnami Tomcat image. It's downloading that. So my Docker image is ready. Yes, I can see the Java app is ready. So let me run this image. So docker run -d -p 80:8080, because the Tomcat default port number is 8080. So I'm mapping the 80 of this mission Docker host to the 8080 of the container. And then the Java app. So once you run this, if you open a browser and try to access the public IP, so this is my public IP. You should be able to see a Tomcat default page, and there my application is hosted under flash. Okay. You just run the snapshot. It will say hello null because I'm not passing any values. And I can pass a value like question mark name equal to doc training. So this will print Docker training. Just once it is deployed, in the URL change your public IP, then you should be able to see that. So in the name, whatever you put, this will be printed. So this will be a typical scenario in your continuous integration system. So where you have a source code and you have the Docker file stored in the source code itself. So your continuous integration system will pull the repo and there it will build it and it will generate a var file or any binary, for that case. And then it will just copy the binary file into the Docker image, and then it will create a application level Docker image. That image, when you run it, you can host the application. This is a typical scenario, what it will be followed in with the continuous integration system. So the next scenario we are going to talk about is called, imagine I don't want do the preparation of the mission for building the application, right? Like for example, in the server we have installed Java, we have installed Maven, okay? All those things we have done, but why can't I do this inside the container itself, right? So I am allowed to do this inside the container itself. I can copy the source code, I can build it, okay? And I can use the container. But the only problem where it comes is like the image size tend to increase a lot, right? If I'm doing all these things inside my image or the container itself, the build step and all those things, it tend to increase the image size, which basically takes more memory, okay? That is where Docker comes up with a concept called multi-stage build, okay? So multi-stage build is a concept in Docker and it is a best practice also. It's ideally a good practice to use it in your Dockerization, okay? So multi-stage build is something like, I will have a container which will build the application and it will generate the var file. From the container, I will just copy the var file or the binary and I will host it on a minimalistic operating system so that my final application image will not be large, will not be huge. So this is what another step, another advantage which is going to bring in your multi-stage build concept, okay? So I'm going to have two containers and that one container will be an intermediate container where it automatically, that in that container I will be building the application and it will be generating the binary file, and in the final application container I will just copy the binary file into it. In that case, I don't need to do any of the preparation, nothing, and I will have a final application image whose size is very less, okay? So for this, let me use a Go app, okay? Go is a language. So I have a separate repository for this. So this is a Go application, okay? So this Go application is just going to print the host name of my mission. So this request was processed by the host and %s shows the host name. Here it will just print the container ID, okay? This is my Go code, and here I have a Dockerfile which basically has which is going to use a Golang Alpine image, and there it can create an app We will come back and talk about what is this work directory. I'll come to that area. And it is copying all the content of my current repo into the app directory. And then it is going to run this command to build my application. And it will create a binary file called main. And that main will be executed to host the application. So this is my Docker container. But I'm going to do it in a multi-stage scenario. I will write my multi-stage Dockerfile separately. Okay. So this is my Go-based application. Here, I'm going to use the multi-stage build. Okay. So first, let us clone this repo. So coming to the server. So here, issue the cd command. So I'm taken to the home directory. Just do the cd command. There, into the git clone, it should have created a folder called Docker multi-build. Let me go inside the Docker multi-build directory. So there, I have a Docker file which will just build that using the Golang Alpine image. So Golang Alpine image is a specific image to host. Search for the Golang app. So this is the Golang official image. And it is having the latest version is stretch latest Alpine 3. Mine is a very old code. So I'm just using the 1.6, 1.164. So I'll just use that, the Alpine. So here I want to highlight about one more image called Alpine Linux. Alpine Linux is a very minimalistic Docker image which has most of the platforms available. His size is only 5 MB, but you'll be able to host multiple applications on it. Okay, so you can use this for hosting multiple applications. It's a very lightweight Linux container or Linux image. If you want to use it, you can use it. This is extensively used across multiple platforms. If you have any Linux-based things, you can give it a try on the Alpine image. Alpine is a very lightweight and very powerful image. So I'm going to use these two images. So first I'm going to build the application using the Golang image, and then I'm going to host the application in the Alpine image because the size will be very lesser for Alpine.